Hi everyone, my name is Thomas Kim. Today is March 13th, 2020. This is my 43rd episode about 3D graphics, Intel TBB OpenCL Vulkan using Microsoft Visual C++. In this episode, I will explain how to get thread affinity mask, also how to prevent resource leak in C++ programming. In our previous episode, episode 42, how to set thread affinity and how to retrieve processor configuration. In this video, we learned how to set thread affinity. In this episode, I will explain how to prevent resource leak in C++ programming, also how to get thread affinity mask. We need source code from our previous episode. If you scroll down episode 42, please double click this link to download the source code from our previous episode. Show in folder, unzip it, rename, 43, GetThreadAffinityMask. Copy the folder, paste it to your working directory. This is my working directory. Start Visual Studio Code. Open the folder. In this folder, right-click, rename, Get Affinity. Hit Enter. Open this file. Ctrl V. I don't think we need these things because these are included in this file already. Now scroll down. Start command prompt. dir cd 43 get thread affinity mask cl ehsc std c++17 get affinity .cpp fe m.exe hit enter cls m. This is the state of our previous episode. Now I will disable this function. Scroll up. I will copy this function. Up to this point, copy. I make demarcation. Paste. Scroll up. Test thread affinity. Prevent resource leak. I will copy the function name, copy, Ctrl+, paste it here. Now scroll up. At line 41, we created a thread. We want to know the type of H thread, like this. Stream type of H thread. Here, talk, play, fun, get type category. Then we pass H thread, and there now we build again CLSM. The type of H thread is void pointer. This is type handle. Type handle is defined to be void pointer. In this application, the cause of problem is between CreateThread function and CloseHandle. If exception is thrown in between, this H thread cannot be closed. This is not exception safe. To prevent this issue, here I create auto close handle auto. If you do not know the returned type, then use forward reference, like this. If you do not know the exact parameter type, then use forwarding reference, auto to %. This is not R-value reference. Auto is a forwarding or universal reference. It can be L-value reference, R-value reference, or pure R-value, or constant L-value reference. etc. Now here close handle, H handle. Now here using unique handle std unique ptr void decl type close handle. This is deleted type. Okay, right click, go to definition. We are using this syntax. dx is default deleted type. Now here I disable this part, unique handle. I create an instance, UH. This is an instance. Now I have to provide pointer, create thread. Now the first parameter, null, stack size 0, thread, fun, then parameter, TP, creation flag. We define the creation flag here. Then thread ID. This is constructor. Why is squiggle? Let me see. I will copy this function name. Sorry, I made a typo. Then I have to provide close handle. Returns thread handle an instance of deleter. Don't forget semicolon. I will modify it like this. Now here auto h thread UH, it has member get. Okay, it returns internal pointer. Then all program works correctly. Now we don't need it. Or we can put a message here. Stream, our thread handle is now closing. And there. Okay. Now we rebuild CLS M. Our thread handle is now closing. So when this block ends, our thread handle is closed properly. This function can never leak hthread handle, no matter what happens in this function. If you do not understand my current session, you probably have to watch my previous episode. If you watched my previous episode, you may understand what we are doing in current session. Also, I highly recommend you to watch Prevent Resource Leak with STD Unique PTR. Please click this link and watch this video. About STD Unique PTR, I filmed 4 videos. This video and up to this video. Now I will give you one more advanced example. Type def struct my thread PARAM pointer P my thread PARAM. So I defined a struct int start and sum bool ready std condition variable cb std mutex. We can also set std thread. Please note that this is pointer p thread. Now scroll down, void thread fun p my thread PARAM. Please note that P, this is pointer, P PARAM. This is our thread function, or it should be reference. Start, end, sum, ready, from this order, we have to preserve the order. cb mutex pthread PALAM. It should be dereferenced. It should be dereferenced. Now I create a block std unique log mutex. Please note that this mutex are all the same thing. cb wait, we provide log, we have to capture as a reference ready, then return ready. Now std this thread yield, we request OS thread scheduler to reschedule our current thread. Now stream current threads logical processor ID. This is global function GetCurrentProcessorNumber. And there, about this function we learned in our previous episode. For your reference, I will copy the link. Now at this point, for int I equals start I less than end plus I sum I, we create a block std unique log mutex stream sum is sum and there. Now we finished thread fun. I will collapse this function void test thread without resource leak. Now I copy this function name, copy, paste. I will disable it. Now here stream main threads logical processor ID get current processor number my thread PALAM my thread parameter. This member I will initialize 1. This member I will initialize 11. This member initialize to 0. This member false. We don't need to initialize it. Cut. I will paste it here. And null ptr. Okay. So I initialize start and sum ready pthread. Here I will change the order, cut, paste. I modified the order. Now here std thread my thread. We initialize this fn, this function, then this function requires parameter. This is pointer. So we have to pass mtp. Please note that this function, in this function, our thread is waiting using condition variable. So we can initialize my thread native handle. It returns handle. So dword ptr. In our previous function, dword ptr thread affinity. I will copy this part and paste it here. I will say 0. Okay, for the time being I will set it 0. Then set GetThreadAffinityMask, we need ThreadHandle. We can get ThreadHandle like this. My thread native handle. Okay? Please understand that my thread is an instance of STD_thread. STD_thread has a member that returns native handle like this. Then we provide thread affinity. MTP has CV notify all. Before we notify, MTP ready true. If this MTP ready turns true, if this ready returns true, our thread function wakes up. If PALAM, this member has ready turns to be true, then our current thread wakes up. At this point, we request OS thread scheduler to reschedule our current thread using yield. At this point, my thread join. Okay? Now we run this function. We build again CLS M. Sum is 55. Main thread's logical process ID is 2. Current thread's logical process ID is 0. This message comes from this line. In this function, the problem is here. We started our thread, and this thread starts immediately. This thread function starts immediately. But at this point, our thread is in wait mode. When this ready, this PALAM's member ready becomes true, then this thread wakes up. Then we request our OS thread scheduler to reschedule. The problem is that from this thread, from this join, if exception is thrown at this part, in between, our application crashes. We have to modify like this. Now here, auto thread join. Auto, this is forwarding reference thread. Don't forget semicolon here. If thread, it is pointer. I will explain why, okay? Joinable. If joinable, then thread join. Now at this point, delete thread. We have to call the destructor of STD thread by calling delete. Now scroll down. At this point, using smart thread handle STD unique PTR. The first type is STD thread. The deleter is DECL type thread join. Okay, we defined this smart thread handle using unique PTR. The member is STD thread. Okay, we have to provide pointer, and the deleter type is thread join. Now at this point, I will disable this. Instead smart thread handle, I create an instance. Now here, new, we dynamically allocate STD thread. This is constructor. Okay, then I have to provide an instance of deleter. This is an instance of deleter. Now here we have to provide thread function, then MTP. Okay, this our thread function starts immediately. This function starts immediately, but at this point our thread function waits until this ready turns to true. So at this point, mtp pthread, please note that this is pointer. We can get this pointer as th get. It returns thread pointer. Okay? It returns thread pointer. In this function, we can also get thread pointer like this. Stream current threads id pthread. We extracted pthread, this thread, through this parameter. It has get id and there. Okay, now at this point we don't need it. Please note that we don't need it. So we can say stream now thread get id is closing successfully and there. Now we run this function 525. I have to fix like this. We build again 504. I forgot semicolon. Now we build again CLS M. Now thread 0 is closing successfully. This message comes from this line. Now thread get id is closing successfully. Please note that now thread 0 is closing successfully. This is correct behavior. When thread join, this lambda is called at the end of this block. When this lambda is called, thread join is called. This means this line of code waits until our thread function ends and terminated. When this thread function terminated, then get id returns std thread id. Default value is returned, and this value is std thread id. If we build this program once again, CLSM, now thread 0, this value should be std thread id, this value is 0. When thread is terminated, get id, std thread id, default value is returned. This is C++ standard specification. If we program this way, after creating thread, even if in this block exception is thrown, our thread function works correctly and no resource leak, no system crash. So you have to know how to code in C++ correctly. Please understand that our thread function is not yet optimized. If you leave questions, I will answer your questions ASAP. At this point, I will define auto GetThreadAffinityMask handle ThreadHandle null ptr auto hthread ThreadHandle is null ptr, then getCurrentThread. This function returns current threads sudo handle, else thread handle dword ptr new thread affinity 0x01 auto existing thread affinity. Set thread affinity mask hthread new thread affinity. We extract existing thread affinity mask. We restore the old thread affinity mask. Set thread affinity mask hthread existing thread affinity. Return existing thread affinity. Now in this function here, string new thread affinity mask. We can do like this to string, and there we call GetThreadAffinityMask. I will copy this text, copy, scroll down. Before we set new thread affinity mask for our thread function, we call this function existing thread affinity mask. About toString function, go to definition, it is defined here. Convert bitmap to string. Now this line displays existing thread affinity of this thread. So STH native handle, we have to provide this parameter. We build once again CLS M. By default, this new thread's bitmask is the same to processor's bitmask. At this point, existing thread affinity mask, new thread affinity mask is displayed from this line. So we set the first logical processor. We can say 0x01, we shift 1, or this is bitwise operator 0x01, we shift 2, this is bitwise operation 3. I will give it bitwise OR. Now if we build once again CLS M, so this bitmask is the result of this bitwise operation. The result of this bitwise operation. There is one caveat in this function. This function is not atomic. So this function should be called in the locked region. I hate lower level programming. OS function calls are low level. C++ threading functions are low level. Bitwise operations are low level. But if we want to be a professional C++ programmer, low-level programming is unavoidable. I will upload complete source code to my website. By the time you watch this video, you can double-click this link and download complete source code. Please subscribe to my YouTube channel. Thank you for watching.